welcome back to this online course by Red Door Analytics, Survival Analysis, an Introduction to Concepts, Methods and Software. In this section, we'll be talking about time at risk. So let's start looking at time at risk. Let's say that we have the following timeline on a population level, where we're interested in time to death after breast cancer diagnosis. So this would look something like this, where on the left-hand side of the timeline, we have patients diagnosed with breast cancer. Then we follow them across this timeline, which is here represented by years since diagnosis, until the event of interest, which is death here represented by the cross. If we transfer this to an individual level, we may have something like the following. Note that we don't have to look at separate individuals. These are just separate observations, but in this example, we're going to focus on these being individuals. Note also that we don't represent whether these individuals have the event of interest or not. We are going to focus on the time aspect here. So on this graph, you can see that we have on the y-axis different individuals represented by these different lines. And they are followed across our timescale, which is times since breast cancer diagnosis to death. So the dashed line on the y-axis represents the time at which these individuals were diagnosed with their breast cancer. If we focus on the individual at the top here, the first individual, we can see that we follow them from their breast cancer diagnosis at the dashed line until they have an event of interest or they are censored at around 5 years. So this means that the time at risk for this individual is 5 years. We can also say that the individual was followed for 5 years in this study. The second individual we follow for a little bit less time. They are followed from their diagnosis of breast cancer again until around 3 years. So the time at risk for this individual was 3 years in this study. And then for the third and the fourth individual, we can see that the length of those lines are exactly the same. They are both followed for 25 years since their diagnosis of breast cancer. So their time at risk is 25 years. So hopefully the figure there showed you that time at risk for an individual or an observation is the time from the start to the stop across our timescale of interest. We started following them from breast cancer diagnosis and we stopped at the time at which they either had the event of interest or they were censored. Now we'll come back to censoring later on in this course. So follow-up time and time at risk is the same thing at an individual level, but it can also refer to the amount of time that all individuals or observations have been followed in a study. So these terms are used almost interchangeably. Usually when presenting time at risk on a population level or on a study level, then we would present time at risk in the form of person time at risk. So the unit would be person time. And this time aspect would either be in years, months, or days. So we would have time at risk in terms of person years, person months, or person days at risk. Again, just note that the stop time is determined by the event date of interest when we're looking at time to event, time to first analyses, which we are in these examples. But it also depends on censoring, which we will come back to. So if we go back to our example where we followed these individuals across the time since breast cancer diagnosis, here we've added the years to the figure. And we say that our study period is only lasting for 20 years. So you can see here that we have another dashed line at 20 years here to say that we're going to say that's the end of our study period. So within the whole of the study, we can look at the person time that has contributed within the study. So if we look at the first individual again, we can see that they have contributed 5 years. The second individual contributes again 3 years. And then this third and the fourth individual, we know that actually we have information for 25 years, but in this specific study example, we wouldn't know that information. So actually they contribute 20 years each. And we can go down all of these individuals and add up the time at risk that they contribute to the person time. And one thing that you may want to do in a study that's often presented is presenting the total person time at risk for a study. So all we would do here to present that is to sum up these values. And here we have time at risk presented in years. If we could present this in a different unit if we wanted to, but if we sum these across the years, what we would end up with is 147 person years. So the entire cohort contributes 147 person years. We can transform the person time to different units depending on what we're interested in. For example, if we wanted to transform these 147 person years to person days, then we could just multiply the 147 by here, 365 days, to get 53,655 person days. We will use person time when we come to estimating rates, because rates are estimated as the number of events divided by the person time at risk. But we'll come back to that in the relevant section. That's everything for this section. Here's some references for further reading. I will see you in the next section.